Hey guys, Mr. Backerberg here. In this video, we're going to look at transformations of sine and cosine graphs. In this video, we're going to be focusing on something called a phase shift. And a phase shift is a horizontal shift either left or right. And what we're going to be focusing on with our phase shift is our c value. Just like when we looked at functions earlier on this year, if we looked at something that had f of x plus c, that plus c inside of the parentheses moved our graph to the left by c spaces. So the same thing is going to happen in here with this plus c, but instead of just calling it a horizontal shift, we call it a phase shift. Now, as our functions get a little bit more complicated, it might be important for us to figure out where our graph is going to start and where it's going to end, especially if we have period changes and phase shifts. So if we want to find where our graph is going to start, we're going to call that our starting point. And in order to figure out where our graph is going to start, we're going to focus on the stuff inside of the parentheses. So we're going to take the bx plus c, and we're going to set that equal to 0. And then what we would do is we would solve to get our x alone. And whatever x value we get is going to be the first x value that we use in our x and y table. Now, if we want to find our ending point, what we're going to do is we're going to work with that stuff inside of parentheses, and it won't matter if it's a sine function or a cosine function. These rules hold true for both of these. We're still going to use that bx plus c, but instead of setting it equal to 0, we're going to set it equal to 2 pi. And then again, we're going to solve to get x alone, and whatever answer we get is our ending x value in our table. So for example, if we wanted to look at the function f of x equals 2 times the sine of 3x minus pi. If we wanted to find the starting point, I would take the 3x minus pi, and I would set that equal to 0. I would add the pi over to the right-hand side, so I would get 3x equals pi, and I would divide the 3 over. So this tells me that we should start our table with an x value of pi over 3. Now, if I wanted to find the ending point, I would take the 3x minus pi, and I would set that equal to 2 pi. I would add the pi over to the right-hand side, so I would get 3x equals 3 pi. I would divide both sides by 3, meaning that the last x value in my table should be pi. So this graph is going to complete one full cycle, one full wave, between the x values of pi over 3 and pi. Now in this example, we're going to look at graphing out a basic phase shift. So we've got our function f of x equals the sine of x, and we've got that table drawn out, and we've got that graph drawn out. The new function that we're going to draw is f of x equals the sine of x plus pi over 2. And we're going to make ourselves an x and y table again. But what's going to happen in here, because we have this plus pi over 2 inside of our parentheses, that's going to take my graph and it's going to shift all of these points that I currently have on there to the left by pi over 2. Now I'm going to find my starting point, and I find my starting point by taking the stuff inside of parentheses, so the x plus pi over 2, and I'm going to set that equal to 0. So I would have to subtract the pi over 2 over to the other side. So my first x value is going to be negative pi over 2. Now to find my ending point, I'm going to take that stuff inside of the parentheses, so the x plus pi over 2, and I'm going to set that equal to 2 pi. Now when I subtract the pi over 2 over to the other side, I'm going to have to get common denominators. So if I'm taking 2 pi over 1 minus pi over 2, well, 2 pi over 1 is really the same as 4 pi over 2. So if I take 4 pi over 2 minus pi over 2, then my graph is going to end at 3 pi over 2. Now if I find the halfway point between negative pi over 2 and 3 pi over 2, that happens to be pi over 2. Halfway between negative pi over 2 and positive pi over 2 is 0, and halfway between pi over 2 and 3 pi over 2 is pi. Now I'm going to take all of these x values and I'm going to plug them into my function. So first I have to plug in the negative pi over 2. But then I have to add pi over 2 to that, so I get 0, and the sine of 0 is 0. If I plug in 0, I have to add the pi over 2. The sine of pi over 2 is 1. If I plug in pi over 2, and I add another pi over 2, that just gets me pi, and the sine of pi is 0. If I plug in pi and add pi over 2, that's 3 pi over 2, and the sine of 3 pi over 2 is negative 1. And if I plug in 3 pi over 2, plus a pi over 2, that's 2 pi, and the sine of 2 pi is 0. So I'm going to have to extend my graph left just a little bit, so I'm going to add one extra line over here, and that's going to be my negative pi over 2. So at negative pi over 2, I'm at 0. At 0, I'm up at 1. At pi over 2, I'm down at 0. At pi, I'm down at negative 1. And at 3 pi over 2, I'm back at 0. So now I can connect all of these dots with my line to get my nice sine wave. And we should notice that our blue graph is basically the exact same as our red graph, just shifted left by pi over 2. Now in this example, we're going to combine a phase shift with a period change. So I've got my basic cosine function with the table and the graph drawn out already. We're going to look at the function h of x equals the cosine of 2x minus pi. So we're going to make ourselves an x and a y chart. Now to figure out where our graph is going to start, I'm going to find the starting point by taking 2x minus pi and setting that equal to 0. I'm going to have to add the pi over to the right hand side, so I get 2x equals pi, and if I divide by 2, I'm going to get a starting value of x equals pi over 2. Now if I find my ending point, I'm going to take the stuff inside of the parentheses, so 2x minus pi, and I have to set that equal to 2 pi. Now if I add the pi over to the right hand side, I get 2x equals 3 pi, and if I divide by the 2, my graph is going to end at 3 pi over 2. Now if I look, halfway between pi over 2 and 3 pi over 2 is just pi. Halfway between pi over 2 and pi is 3 pi over 4, and halfway between pi and 3 pi over 2 is 5 pi over 4. Now I'm going to start plugging these x values in. So I'm going to start with the pi over 2, and the first thing that I have to do is multiply that by 2. So pi over 2 times 2 is just pi, but then I have to subtract pi from that. So we get 0, and the cosine of 0 is 1. Now if I plug in 3 pi over 4 times 2, I get 3 pi over 2. But if I subtract pi from that, then I just get pi over 2, and the cosine of pi over 2 is 0. If I plug in pi, 2 times pi is 2 pi, minus pi is just 1 pi, and the cosine of 1 pi is negative 1. If I plug in 5 pi over 4 times 2, I get 5 pi over 2. But if I subtract pi from that, I should get 3 pi over 2, and the cosine of 3 pi over 2 is 0. Now if I plug in 3 pi over 2, 3 pi over 2 times 2 is just 3 pi. 3 pi minus pi is 2 pi, and the cosine of 2 pi is 1. So I'm going to have to add in a couple of extra dash marks, a dash mark between pi over 2 and pi to represent my 3 pi over 4, and a dash mark between pi and 3 pi over 2 to represent my 5 pi over 4. So at 5 pi over 2, I'm supposed to be up at 1. At 3 pi over 2, I'm down at 0. At pi, I'm down at negative 1. At 5 pi over 4, I'm up at 0. And at 3 pi over 2, I'm up at 1. And I can connect these dots with my line to get my cosine curve. Now we should notice two things happened. Number one, our graph got shifted to the right. So instead of starting at 0, we started at pi over 2. And instead of our graph taking a full 2 pi to complete one full cycle, we were able to complete one full cycle between pi over 2 and 3 pi over 2 because the 2 in front of our x shortens the period. That's going to be it for this video. Thanks for watching.